All right, this is the midterm review guide. So starts with question number 1, which of the options is not a derivative? So this involves knowing what the derivatives are. So for our derivatives, remember that's going to be a small rate of change. So if we look at all of our choices, meters per second is a rate of change. Money lost per year is a rate of change. Trees per city is a rate of change. Cats is not a rate of change. Fish per tank is a rate of change. So this is the idea is D. So again, here we're just talking about the general idea of what a derivative is, which again, we're looking for a rate of change. Based on the units, again, that's a something per something, so we know that D isn't the right choice. So D is not the derivative, so we pick D. All right, for number 2, function f is a property that as x gets closer to 2, the value of f of x gets closer to 4, which must be true. So I'm going to say that as x approaches 2, we want that limit of f of x to be 4. So our choice that we have is going to be, again, D in this case. So again, since we're getting closer, we're not finding out exactly what we are. We can get rid of all of these f of x's, and that just leaves these two options, which when we want to get closer to 2, we don't want to get closer to 4. All right, for number 3, we have our graph. We have to find the limit as x approaches 1. So the first thing to remember is that we're trying to go from both the left and the right. So this hole right here doesn't really matter because we don't use the function value at all. So we can fill in that hole if we wanted to. And it looks like we're headed towards 2 on the y-axis. So from the left and the right, we're both headed towards 2. So we would pick 2 in this case. For number 4, we've got our table. Based on that, what's the best approximation for the limit as x approaches 2 of f of x? Again, if there were a 2 inside this table, we would ignore whatever it is. There's not, so we don't really need to care about that. But we do need to check from both the left and the right side. So from the left side, looks like we're headed down to 4. And then from the right side, looks like we're headed up to 4. So since we're approaching 4 on both sides, 4 does equal 4. So we want to pick 4, which is going to be C. For number 5, we have to find out which function the limit as x approaches 2 pi of f of x equals 1 is true. So we have a whole bunch of trig functions here. So we're going to have to decide from our trig functions which one actually gives us 1. So let's check this out. So if we put in, since we can kind of plug in 2 pi for all of our trig functions, cosine of 2 pi does equal 1. So that seems like we're going to pick that one. Cotangent of 2 pi. So remember, cotangent is going to be not sine over cosine, but the other way. So cosine of 2 pi over sine of 2 pi. So that would be 1 over 0, which would be undefined. If tangent's in here, tangent is in here. Tangent would be the inverse. Tangent would be 0, so we'll get rid of tangent right now as well. Sine of 2 pi, that would be 0, so we can get rid of sine as well. And then cosecant, remember cosecant is going to be 1 over sine. Oops, cosecant of 2 pi is 1 over sine of 2 pi. But we know sine of 2 pi is 0, so we'd be back in this 1 over 0 situation. So we do have to try them all, even though it is multiple choice, useful to try them all, just in case they'll give us one of those 1, 2, or 3 choices. For number 5, we find the limit as x approaches 3. A couple ways to do this since we've gotten so far in the class, but this one, I think this person said it came from Unit 1. So we'll solve it like a Unit 1 question where we see we've got x minus 3 and x to the third minus 27. We try plugging 3 in, and we can see that we get 27 minus 27 over 0, or 0 over 0, which is indeterminate form. Again, if you want to solve this like a L'Hopital, you can choose to L'Hopital this one. But since it's like a Unit 1 one, I'm going to go ahead and solve it like we did back in Unit 1. And back in Unit 1, what we did is we said, well, we could factor cancel these. So we're going to factor cancel it. Because this right here is just an a cubed minus b cubed. So we know that this factors into a minus b times a squared plus ab plus b squared. So that's going to become the limit as x approaches 3 of x minus 3, x squared plus 3x plus 3 squared all over x minus 3. And now my x minus 3s are going to cancel. So if I try to plug in from here, remember I've got the 3 here, I'll have 3 squared plus 3 times 3 plus 3 squared. So that's going to be 9 plus 9 plus 9, which is 27. So we do get C. Now again, if we L'Hopital it, I mean, it's pretty quick. We can see that we'll get 3x squared. 3 times 9 would also give us 27. So you could L'Hopital it if you wanted to L'Hopital it. But this is from Unit 1, according to this person, so I'm solving it like we did from Unit 1. For the next one, we're going to find another limit as x approaches 3. So we just do the same thing when we try it again. So 3 squared minus 3 plus 5 over 2 times 3 plus 4. 3 squared would be 9 minus 3 plus 5 over 6 plus 4. So that's 6 plus 5 is 11 over 10. And since substitution worked, we're done. There's nothing else to do with that one. So the answer is C. For number 8, we've got the limit as x approaches 4 of f of x is 5, the limit as x approaches 4 of g of x is 5, and we also have the following inequality. So what they've set up here is we've satisfied both conditions to use the squeeze theorem. So by the squeeze theorem, we know that the limit as x approaches 4 of h of x has to equal the limit as x approaches 4 of f of x, which should be the same as the limit as x approaches 4 of g of x. Since these are both 5, we know that the answer then has to be 5. For 9, we have to find out where this is not continuous. So again, we have to think about where this would not follow all 3 continuity rules. So it has to break either that f of c does not exist. It has to follow that the limit as x approaches c, this should be f of x, of f of x, that should be a c. I had it right the first time. The limit as x approaches c of f of x does not exist, or that the limit and f of c are not the same. So if one of these happens, then we are not continuous. So just looking at our function here, we've got 1 over x minus 2 squared. If I were to plug in 2, I know I would get 0 on the denominator. 1 over 2 minus 2 squared, is going to be 1 over 0. And 1 over 0 is not defined, so I know that it's got to be 2. Again, I can kind of tell that just by looking at it. I guess I should do it out fully and say I don't want the denominator to be equal to 0. So I could do x minus 2 squared is not equal to 0. Square root both sides. Add 2 to both sides. And get x does not equal 2. I could solve for it if I didn't want to do it by inspection. And that's about it. So we only have to pick one choice. Again, you could test all of the other choices if you wanted to, if this was one of those 1, 2, or 3 choices. But in this case, we got. All right. All right, so this is number 10, which the following is not continuous. So if we look at our first one, our first function here, this is a polynomial. And we know that polynomials are always going to be continuous. This one wants to know where we're not continuous. So since this one is continuous, we get rid of this one. Here we have a rational function. Rational functions are sometimes continuous. So we'll leave that one in the mix because it's a rational function. This one looks like it's a rational function, but you can really rewrite this one as 2 over pi times sine of x. And sine of x is always defined. So if you remember back from previous classes, sine of x kind of looks like that, and I guess it extends this way as well. So since sine of x is always defined and pi is just a number, we're never going to get a chance to break this, where we would have either 0 on the denominator or a negative inside of a radical. So we'll get rid of that one. Same deal with e to the x. I mean, that's not a fraction. We're never going to get 0 out of this, so we can go ahead and get rid of L of x. And k of x looks like it's a rational function. But if we look at 1 plus e to the negative x, 1 plus e to the negative x is never going to, this e to the negative x here, is never going to give us a negative number. So if you remember from all of your exponentials, you would know that this would approach asymptotically towards 0. We would never actually get to 0 or a negative number. So this denominator is never going to give us 0. So we'll never actually break that function. So it turns out the only one that could break is going to be b. Now we would have to say, all right, is there some place where x to the third plus x squared plus x plus 1, is there a time that this would actually equal 0? So, I mean, we got to kind of think about it. By the rational root test, luckily with our p's and our q's, the only thing we would have to check is plus or minus 1. Positive 1 would be silly since everything is positive. So we'll check negative 1, 1x to the third, 1x squared, 1x, and 1. Do some synthetic division, negative 1, 0. Negative 1 times 0, 0. Add them up. Negative 1 times 1 is negative 1. We do get 0. So if we were to plug negative 1 into the function, we actually do get a 0. And we could also have told, because we have an odd number here, so for an odd degree, you have to have at least one real 0. So we could have used some logic that way, but it's good to prove it with some of our previous math. Note the other two solutions here would then be imaginary. X squared plus 1 equals 0. X squared equals negative 1. So x would be plus or minus I. We wouldn't really count those in terms of continuity. But since we do have the one real 0, yeah, it has to happen. So B is actually not continuous. Kind of cool question. Number 11, we have to see if Guillemot de L'Hopital is actually going to have us do L'Hopital's rule. And if we plug in infinity, what we would get is we would get some number for sine of 2 times infinity. So it's going to be a number. Plus 7 times infinity squared would be infinity squared, minus 2 times infinity, so minus infinity, over c squared would be infinity squared. 7 plus 1 is 8, so times 8 squared. So in this case, we are going to get infinity over infinity, and Mr. L'Hopital can be used. So we can use L'Hopital's rule because infinity over infinity is an indeterminate form. So we can actually proceed. So let's take the derivative of the top. Derivative of the top is going to be derivative of sine is cosine of 2c. We're still doing the limit as c approaches infinity. Times 2, because we have to do the chain rule with the 2c inside. 7c squared would be 14c. 2c would be down to minus 2. Then we would get c squared. Remember, this is just 64. So we'll write that as 64 times c times 2, 128c. Now, if we plug in infinity this time, we're going to get 2 times a number, so some number for the cosine of 2c, plus 14 times infinity is infinity, minus 2 is just minus 2. 64 times c times 2 is going to give us infinity. So it turns out, again, we get infinity over infinity. We have another L'Hopital. We have another indeterminate form. We can do it again. So we could double L'Hopital it. So that's pretty cool. The limit as c approaches infinity then, derivative of cosine is negative sine 2c. I have to multiply again by 2 for the chain rule, so times 2 squared, plus derivative of 14c is 14. Then I get minus 2, but that's going to become 0. Down here, I've got 128, so that's kind of nice. All right, well, let's plug in infinity and see what we get this time. This time when we plug in infinity, we get a number plus 14 over 128. Now, the thing is, this number, we don't really know what this number is because this number is dependent on sine. So this number is going to oscillate. Since this number is going to oscillate, this is going to end up being DNE because it's going to oscillate between, the sine part's going to go between negative 1 and 1, but since we've got 4 out front, it's going to oscillate between negative 4 and 4. And since we can't actually pin down where that's going to be, the answer to this one's actually DNE. This one does not exist. This is a pretty cool one that you get to use L'Hopital's rule and not actually get an answer. So it's a fun one where you get indeterminate form, and indeterminate form actually gives you DNE. So pretty cool. I like this question a lot. That was a good one. For number 12, we have to evaluate the limit as x approaches 3. Again, we kind of have our choice. This was from the section where you basically have your choice as to how you want to solve this one. I feel like factor cancel is going to be a good choice here. Top factor is pretty quick. x minus 3 times another x minus 3. Bottom is x minus 3. Those cancel. 3 minus 3 is 0. And so we're all set. For 13, we have this table. I guess it's the table below. I gotta go fix that. So we've got functions of x, which are the following statements if true would be individually sufficient that there conclude there exists a number such exists a number c in the interval from -2 to 2 such that g of c is equal to 6. So the idea here is we want to set up the intermediate value theorem. So since we need to set up the intermediate value theorem, we need two things for the intermediate value theorem. First thing we need is we need a closed interval. We got that. We have our closed interval, so that part's done. So we don't need that. The second part we need is we need to be continuous over the interval. So in order to be continuous over the interval, we'd have to pick one of our choices here. To be continuous, wouldn't be good enough to just be defined, because again, if we're defined, we could have like a step function, so that won't help out. Increasing doesn't count. Increasing is not continuous. The one that's continuous is going to be choice 3, so we're going to go with B, 3 only, because that's the one that would be continuous. All right, for 14, line tangent to the graph passes through the point 2, 6. I think we need and passes through the point -4, -6. We have to find the derivative at 2. So since our line tangent is going to pass through 2, then that means that the slope of this line is going to be tangent to the original function, which means it's going to be the derivative. So with this one, we can just use our slope formula. M equals y2 minus y1 over x2 minus x1. Here we'll go x1, y1, x2, y2. So -6 minus 6 over -4 minus 2. -12 over -6, which is 2. So our slope here is going to be 2. Again, it's going to be the slope is going to be the derivative at 2. But it's only f prime of 2. It wouldn't be f prime at really any other value. So that's what we got. For 15, y equals x squared. We have found the limit as h approaches 0 of f of 0 minus f of 0 minus h over h. So again, this is telling us to take the derivative and then evaluate at 0. A little bit strange here. They kind of flip-flop these. So technically, we're going to take the negative of the answer. Since we have the positive version. So we do need to take the negative. So apply a negative at the end. But with this one, I mean, the derivative of x squared is just going to be 2x. And when we plug 0 in, we're going to get 0. So -0 doesn't really do much, but the answer is going to be 0. So that's what we got for that one. For 16, find the derivative of x to the first power. So this is an easy one to overthink. It's just x. Find the derivative of x. We could use the power rule if we want. Bring the 1 out front. 1 minus 1 is 0. We're just going to get 1. For 17, we got to find the derivative of 7. Derivative of all constants is 0. For 18, we have to find the derivative of cosine of x. We have to memorize this one. Cosine of x, derivative of that's going to be negative sine of x. No tricks there. Just don't overthink it. Pick B and move on. Derivative of the function 2x times sine of x. I mean, pretty clearly this is going to be a product rule. So we'll do first times the derivative of the second. Derivative of sine of x is cosine of x. Plus the second, sine of x, times the derivative of the first, which is going to be 2. So we get 2x cosine of x plus 2 sine of x. Let's see, I got a 2x cosine of x and a 2 sine of x, so I'm going to pick A, because that's what I got. So there we go. For number 20, now we've got a division, so it looks like we're going to have to use the quotient rule here because we have to find the derivative. So for quotient rule, we'll go low d high, derivative of 2x plus 1 is 2, minus high, so 2x plus 1, d low, that's going to be 1, square the bottom, and away we go. So, whoops, not x squared, x plus 2 squared. All right, so I don't have that as any of my answer choices. That means this question creator wanted us to multiply everything out. So 2x plus 4 minus, that's where we get the 2x and 4, minus 2x minus 1. X plus 2 squared is x squared plus 4x plus 4. 2x minus 2x is actually going to cancel out, which is kind of fun. 4 minus 1 would be 3 over x squared plus 4x plus 4. So there we go. So we get C. So this person wanted us to actually do some extra algebra in addition to the calculus. And sometimes you might just see this calculus version as the answer, as an answer choice. And this person wanted us to go a little further. All right. For the next one, we've got x squared. F of x is x squared plus 2x. We have to find the derivative of f of ln of x. So since we're taking a derivative of a composition, this is going to be a chain rule. So we have to do a chain rule here. All right, for this chain rule, the inside function is pretty clearly ln of x. So du is going to be 1 over x. Now our outside function is f of x. That'll be f of u in this case. So that means that our derivative we have to take from the original function is going to be 2x plus 2, or in this case 2u plus 2. All right, so what we have to do is then we have to plug the u back in. So we'll get 2 ln of x plus 2. And then we have to multiply this all by 1 over x. So the nice thing is we can just kind of say, instead of times 1 over x, we can say 2 ln of x plus 2, and then just divide by x. And that is answer choice E right here, 2 times ln of x plus 2 over x. So we're going to pick E in this case. All right, for 22, we got to find the derivative of cosine of 3x, another chain rule here with the trig. So the derivative of cosine is negative sine. And then we can say, well, the derivative of 3x is 3, so negative 3 sine of 3x. For 23, we have to find the slope tangent to the curve. And here we've got y to the third x plus y squared x squared equals 6. So since we got the y's with the x's, it's a good choice to do the implicits. But it's the implicits with 2 product rules, not just 1, but 2 product rules. So this was made a very fun question. So that's really good. So first one, we got y to the third. Derivative of the first is just 1, or sorry, derivative of the second is 1, plus x times the derivative of the first, 3y squared, oops, not a parentheses, dy dx. And then we have to do the second part here. So we've got y squared first times the derivative of the second. So that would be 2x plus the second x squared times the derivative of the first, which would be 2y dy dx. And then derivative of 6 is just going to be 0, so equals 0. Next step, we get everything that's not a dy dx on the other side. So we'll start moving things around. So minus y cubed and minus 2xy squared. So that's going to give us 3xy squared dy dx plus x 2x squared y dy dx equals negative y to the third minus 2xy squared. GCF out the dy dx. 3xy squared plus 2x squared y equals negative y cubed minus 2xy squared. Divide everything by this 3xy squared plus 2x squared y plus 2x squared y. And now we have to do one more part. We have to plug in 2 and 1. So this is x and this is y. So dy dx is equal to negative 1 cubed minus 2 times 1 squared over 3 times 2 times 1 squared plus 2 times 2 squared times 1. So this is negative 1 minus 4 over 3 times 2 is going to be 6. 1 squared. 2 times 2 times 2 is 8 plus 8. So that's negative 5 over 14. And that is an answer choice. That is answer choice D. So nice implicit question. We had to go through all 4 steps of the process, and we also got to do the substitution. So very cool. Very nice. All right. Next one, 24. We've got x. F of x is x to the third minus 2x squared minus 7x plus 1. G of x is the inverse, and g of 2 is equal to 3. We have to find out what g prime of 2 is. So we have to remember our inverse formula. G prime of x is 1 over f prime at g of x. So we have to find g prime of 2. So g prime of 2 is 1 over f prime at g of 2. So that's 1 over f prime. G of 2 is 3, so of 3. So that means we need to take the derivative of this one. So f prime of x is going to be some power rules here. So we get 3x squared minus 4x minus 7. Now we can see we're plugging in 3. So we have to plug in 3 for x. We don't plug in 2 for x. We plug in 3 for x. So we'll get 3 times 3 squared, that's 27, minus 4 times 3, that's minus 12, minus another 7. Fastest way to do that would be 27 minus 7 is 20, minus 12 is 8. So we get 1 over 8. And that's our result. So that's what we got for 24. All right, 25, find the derivative of arc sine of x squared. So for this one, we have to remember our formula. Our derivative is going to be u prime over square root of 1 minus u squared. All right, well, u in this case is x squared. So du, or u prime, is going to be 2x. So we get 2x over square root of 1 minus x squared squared. And that would be x to the fourth. Easy only choice with an x to the fourth, so we're going to go with that one. For 26, y is equal to x squared plus 1 squared, dy dx. So it's another chain rule. In this case, though, kind of cool because we could choose to use the general power rule instead. So 2x squared plus 1, now to the first power, times the derivative of the inside, which would just be 2x. So this will be 4x x squared plus 1. 4x x squared plus 1. All right, there we go. Looks like we got it. That's it. So that's it for 26. Next one, we have a really, really big tractor. We're driving down the straight road. We've got our equation for position here. Remember, position is going to be s of t, even though it doesn't say specifically this is position. This is position. Find the truck's acceleration. So that means we need to find the second derivative. So s prime of x is v of x. So that's going to be 3x squared plus 5. S double prime of x is going to be v prime of x is going to be a of x, which is going to be, in this case, 6x. So when we plug in 0.5, 6 times 0.5, we're going to end up with 3. So we'll pick A on that one. Notice the person did the x's instead of the t's. Usually we see the t's. They want to do the x's, so we deal with the x's. 28, we've got C of t models the amount of coats in the world in millions. T is the number of years since June 6, 2020, which of the following is the best interpretation of the statement C prime of 1 equals 1.56. So now we want to find out 1 year later. Notice it's a derivative. So for a derivative, this is going to be an instantaneous rate of change. So we don't want an average. We want to know exactly at that one point. So it would be on June 6, 2021 is what we're looking for. So for every one person, that's not what we're looking for. Every year, that's not what we're looking for. We're looking for that very specific 1 year after. On June 6, 2021, that's what we're looking for. Amount of coats in the world was decreasing. That's not what we have because we have a positive number. So we have a positive rate of change. Every month, that's not what we're looking for. We're only looking for just at that specific date on June 6, 2021. So again, that's what we're looking for. Amount of coats is increasing at a rate of 1.56 million coats per year. Yep, we are in millions, so it looks like we're good to go. So we want to pick E in this case. For 29, we have firework A has a positive velocity v of t being launched upwards from initial height 0 at time t equals 0. Velocity of the rocket is shown in the table. This needs to be below again. Find the average acceleration. So this time we are finding the average. So we're not finding the derivative. We're using the average acceleration. So we need the average rate of change formula. And we're going to go from 0 to 41 seconds. This is going to be like x2, x1 and x2. All right, so our average rate of change formula, that's just the slope formula. y2 minus y1 over x2 minus x1. Here we've got x2 and x1. They're given in the problem, 40 minus 0. We look those numbers up. We've got 36. We've got 4. So that's going to give us 32 out of 40. Looks like we want to reduce. That's pretty common to do in these problems. We can divide them both by 8. So we're going to get 4 over 5. And that's the only one that's 4 over 5. So even though they needed to include units of measure, this person didn't try and trick us with the units of measure here with the 4 over 5. There are a couple that are feet per second, but again, our acceleration is going to be measured in feet per second squared. So, I mean, we could have gotten rid of these ones right away, but our number kind of led us to the answer already. So that's what we got for 29. For number 30, we're told that we have the equation v equals xt. So that's a pretty cool equation. V is the volume, x is a constant. So that's interesting. We're not actually going to do anything with x. T is the temperature, which represents the rate of change with respect to time of the volume and the temperature. So we wanted to go ahead. It's kind of like a Dreads question. We take our derivatives, but we want to do it with respect to time. So dv dt, and x is a constant. So we don't do anything with x. T, we go d capital T, d lowercase t. And I think that's actually the end of the question because we just need to set up the relationship. So that's going to be D, and we're going to be done with that one. For 31, someone's rectangular head. So this sounds like a Dreads question. So we'll draw our head. That's our rectangular head. I think our person's going to be happy this time. We'll make our person happy. But we have a width of 7 meters and a length of 4 meters. So I guess I kind of drew my head the wrong way. That's okay. We'll just switch these. We'll make our drawing a little bit nicer. Let's go this way. A width of 7 and a length of 4. But our person should still be pretty happy. They're just going to be really happy. All right. So in this case, we can set up our rate box. Width is 7, length is 4. The length is constantly changing at a rate of 2 meters per second. So we know that the L dt is 2. The width is constantly changing at a rate of 3 meters per second. So dw dt is equal to 3. What is the rate of change of area of the head? So we want to find dA dt. That's our goal. That's going to be our question mark. So let's lock that all in. Nice, it's a rectangle. So the equation step is going to be, we're finding area. So area is equal to length times width. We'll take our derivative next. dA dt is equal to, and since we're multiplying here, this is a product rule. So we have to use the product rule on this one. So first times the derivative of the second plus the second times the derivative of the first, dL dt. So we'll plug everything in that we've got. So we'll substitute and solve. So dA dt is equal to L is 4, dW dt is 3, W is 7, dL dt is 2. So this is 12 plus 14 for 26. And that's going to be our d8 dt. The units aren't given here, so sometimes they like to give you the units. This person didn't, but it would be meters per second, meters squared per second, because we got meters times meters per second. So, all right. 32 cones filled with water at a rate of 4 inches per minute, 4 inches cubed per minute. Cone's got a height of 20 inches, diameter of 10 inches. Find the rate of change of radius when the cone is filled to a height of 5 inches. So, looks like another dreads question. Which is cool. We had, I think, both 4-4 and 4-5. I think we're both dreads. So we'll start off by drawing our cone. In this case, the whole cone has a height of 20. And since we have a diameter of 10, we know that the radius is going to have to be 5. For our rate box, we're told that the height, that's the height of the cone. We need to find out the cone is filled to a height of 5 inches, so h is equal to 5. But we need to find the rate of change of the radius. So dr dt is going to be our question mark. We also know how we're filling it, so dv dt is going to be 4. So since we're dealing with r and v, we actually don't really want this h. We actually want to find out what the radius would be. So in this case, if we look, we are going to be in proportions of 4 to 1 for the height. So the radius is going to be the height divided by 4. So our radius is actually going to be 5 over 4. We'll lock that all in. And then we have our equation, a pretty standard equation of a cone, 1v equals 1/3 pi r squared h. Again, since we want dr dt, we want to get rid of this h. So the height is going to be 4 times as big as the radius. So the volume is 1/3 pi r squared times 4, not h anymore, this is now 4r. So this is going to be 4/3 pi r cubed. So kind of cool. So this person said it so that when we actually make the substitution, we actually end up with the volume of a sphere. So that's kind of nice. We'll do the derivative. So the derivative of volume is just dv dt. Derivative over here, then we're going to end up with the power rule, we get 4 pi r squared dr dt. Because again, the 3 will come down and cancel out the 3 right here. All right, so then what we got is we've got our radius. So what we need to do is we need to plug everything in. We're on substitute and solve. So let's go ahead and do that. dv dt is 4. The radius is 5/4. We're going to have to square that. And dr dt is what we're trying to figure out. So that should just stay as is, should just stay as dr dt. So we can divide both sides by 4 pi 5 over 4 squared. So the 4's are going to cancel. So we're going to get 1 over pi 25 over 16 is equal to dr dt. But 25 over 16, since it's on the bottom, we can flip that to make that 16 over 25 pi for dr dt. And that's going to be answer choice E. So that's what we get for that one. For 33, apple tree on a hill has its height in feet measured t years after it was planted is the differential function h of t. H of 8 is 10, and the derivative at 8 is 1/2. Approximate the height of the tree when t is 8.5 years. So we see we're doing an approximation. So we're probably going to use a local linearization here to make the approximation. So y minus y1 equals mx minus x1. So in this case, what are we given? We're given h of 8 equals 10. So this is going to be x1 and y1. We're told what the derivative is at 8. So we're told that 1/2 is going to be m. And we're trying to find it at 8.5 years. So we know that that's x. So we've got almost all of our pieces, right? We've got y minus 10 is equal to 1/2 8.5 minus 8. So if we add 10 to both sides, we're going to get 1/2 of 1/2 plus 10 is 10.25. So we're going to answer choice C for that one. All right, last one, 34. Find the limit as x approaches 2 of 2x minus 4 over x minus 2. And you can do this in many different ways since it's right at the end, probably L'Hopital here. So we're going to L'Hopital this one. Let's just double check to make sure we can. 2 minus 2, that's going to give us 0 over 0. So yeah, that's indeterminate form. So this is a L'Hopital. All right, so let's take the derivative at the top. The limit as x approaches 2 of 2 over 1. Well, there's nothing even to plug in anymore. It's just always going to be 2. So there we go. Looks like we got it. So it looks like our limit as x approaches 2 is just going to be 2.